Okay, so today we're going to be looking at 7-1. This is the worksheet that has equations with variables on both sides. So basically what I'm going to do is I'm going to pick out a few questions from this page and basically kind of work through one from every section, and it should kind of come back to you. So feel free to skip around if you're only looking for like a specific type of question. But basically I'm going to do number 3, I'm going to do number 6, I'm going to do number 9, and finally, I'm going to do number 12. I'm going to do every third problem here, okay? So you guys are going to complete the whole page, but if you're having trouble with this one, you can kind of work along with me here and solve these problems, okay? So the first thing we want to do is I want to just kind of refresh you guys on the rules of equations, okay? So I'm going to do a quick version of what we did in class when we started equations back in 7th grade, and we repeated it again here in 8th grade, okay? And so if you remember, I started with a really simple equation, 2 plus 4 equals 6. Okay, and so what we did is I told you guys to kind of start messing with this equation, changing it by using some sort of operation. So for example, if I wanted to add 2 to the left side of my equation, I can do that, right? So that's not going to change this 2. Okay, so that 2 is going to stay the same. I'm just going to bring it down. Okay, 4 plus 2 is going to give me 6. Okay, but now if I just bring down the 6 from over here, I have 2 plus 6 equals 6. Okay, and that's not true anymore. So I can't just take a 2 and add it to the left side of my problem. Okay, and when I talk about the left side, I'm talking about around the equal sign. Okay, so when I say the left side of the problem, I mean to the left of the equal sign. If I say the right side of the problem, I mean to the right of the equal sign. Okay, so notice how the left side of our equation equals 8, but because we didn't change the right side at all and just brought down our 6, the answer there was 6. Okay, so remember that means that in order to add 2, we can do that as long as I add 2 to the other side as well. Okay, so if you remember, when I'm adding and subtracting, as long as I do something to one side, I do the same thing to the other side, and that will make my equation true, because now, with that, I have 2 plus 6 equals 8, and that is still a true statement. Okay, so I could add whatever I want, right? If I wanted to add 10 to both sides, I can do that. 4 plus 10 is 14. 6 plus 10 is 16. And if you look, 2 plus 14 is 16. Okay, so I can add or subtract whatever I want as long as I do the same thing from one side as I do to the other. Okay, we also need to look, though, at multiplication and division. And it turns out that they are similar but slightly different. Okay, so the first place we always start is we just follow the same rule, right? If I multiply by 2 on one side and I multiply by 2 on the other side, let's see if that works. Okay, so I just picked multiply by 2. You could multiply by anything or divided by anything. We're going to look at division in a second, but I just picked 2 because it's simple and easy. Okay, 2 times 2 is 4, plus 4, just bring down this 4, equals 6 times 2, which is 12. Okay, and you can pretty obviously tell that 4 plus 4 is not equal to 12. Okay, but watch what happens if I multiply the 4 by 2. Okay, now 4 times 2, that gives me 8. Okay, so 4 plus 8, that is equal to 12. Okay, so there's a subtle difference here with addition and subtraction and multiplication and division. Now I didn't show the division. Let's do one real quick. Okay, so we have 2 plus 4 equals 6. Okay, and I'm just because they're all even numbers, I'm just going to divide by 2. Okay, and again, if I just divide by 2, same thing I did over with the addition problem, once on each side. 2 divided by 2 is 1, plus 4 equals 6 divided by 2, which is 3. 1 plus 4 is not equal to 3, okay? But, again, if I do it to every term, the 4 gets divided by 2 as well, and that gives me 2. 1 plus 2 equals 3. That is a correct answer, okay? So the reason why I'm showing you guys this is these are all of the rules you'll need to solve these problems, okay? If I'm adding, I need to add to both sides of the problem, adding or subtracting. I need to add or subtract the same thing on both sides of the problem one time, okay? If I'm multiplying or dividing, I need to multiply every part of the equation by whatever number I'm multiplying or dividing by in order to keep my equation true, okay? So with that, let's go ahead now and look at our problems. Now, if you remember, when we're solving equations, we are looking to figure out what our variable is in each problem. So I know that I'm going to be done with this problem when I get x equals blank. Okay, so you're probably going to want to get an extra piece of paper or something on this one, because there's really just not, even if you write really small, there's not enough room to write the work below these equations, okay? So go ahead and get an extra piece of paper, or do it on the back, or find an extra place to do it, okay? Because it's going to be tough to work it on this page, okay? So I'm going to give myself some extra room over here and just rewrite the problem. X minus 2 equals negative 3x plus 2. Okay, so again, remember that the goal of this problem is to get x alone. And specifically, I want only one x. Okay, remember that a single x by itself, just like we have at the end of the problem there, means that I have one x remaining. Okay, so let's go ahead and look at our problem and see if we can analyze what we should probably fix first. So I have x minus 2 equals negative 3x plus 2. And personally, when I tackle these problems, I like to get rid of one of the variables first. Because if you remember, in the final part of this problem, I don't want an x on both sides of my equation. If I have an x on both sides, I'm not actually going to figure out what x equals, okay? So the first thing I'm going to do is I'm going to get rid of one of these. And personally, I like to get rid of an x so that I'll be left with a positive value. Negatives add extra problems. They give us lots of chances to make mistakes. So I'm just going to leave it as positive if I can. Okay, so I have an option to get rid of this x, or I have an option to get rid of this negative 3x. Okay, now personally, I'm going to get rid of the negative 3x. And again, the reason for that is because I'm going to make it positive, right? If I want to make a negative 3 disappear, or in other words, cancel and go to 0, okay, then I need to add 3x on both sides. Okay, so I'm going to add 3x to this right side of my problem, again, to make a 0 there. And I'm going to add 3x on this side, okay? Remember that when you add something with an x, like we have here with the 3x, I can't add it to something without an x. That would be an unlike term, okay? So that's going to leave me, x plus 3x would give me 4x, because again, remember, a single x by itself is basically 1x. Okay, and then I'm just going to bring down everything else I haven't used yet. So notice I didn't use this minus 2, so I'm going to put the minus 2 down here. Bring down our equal sign. Okay, now negative 3x plus 3x, that goes away, that becomes 0. So all I'm left with then on the right side of my problem is just the 2. Okay, and remember, we don't need to worry about writing this 0 here because there is the 2. We don't need that 0 because 0 plus 2 is just 2. Okay, so let's just save some time and not worry about writing down the 0. Okay, so now notice we've gotten closer to solving our problem. Now I don't have two x's to deal with anymore. Now I've only got the 1 that I'm going to be left with at the end of my problem. Okay, so that means now I need to start isolating the things that are on the same side of the problem as x. And again, remember when I say that, I mean to the left of the equal sign, because that is where my x is. Okay, so that means that I need to get rid of, at some point, the positive 4 here and the negative 2 here. Okay, so if we think back to those rules that we just talked about, now I can get rid of either one of these at any point. Okay, the negative 2, I want to turn into a 0. I want to make it go away because there's nothing next to the x here. There's nothing left on the side away from the x. Okay, so I'm going to need to make the negative 2 into a 0, and I'm going to need to make this 4 into a 1. Okay, because if you remember, I'm left with 1x at the end of my problem. Okay, so I could, if I wanted to, divide by 4. And if you remember, it's division because we're doing the opposite of the multiplication that's between the 4 and the x. But if I do that, I have to divide everything by 4. And now we just made a bunch of fractions that weren't there before, okay? And not that we can't deal with fractions, but it's going to be much easier if we don't, okay? So instead of dividing by 4, you're pretty much going to save the division for last, okay? Division will almost always be our last step because of that idea. So instead, I'm going to add 2 to the left side and add 2 to the right side. Okay, so that's going to make my 2's disappear on the left side. Negative 2 plus positive 2 is going to give me 0. 2 plus 2 is going to give me 4. And then I just bring down everything I haven't used. So while this became 0, I still have a 4x on the left side. Okay, so I'm just going to bring down the 4x to continue my problem. Okay, and I'm almost done now, right? I'm almost to the point where I have x equals whatever the number that it's going to equal. Okay, so the way I'm going to finish it is, again, remember, I'm trying to turn this 4 into a 1. Well, the easiest way to turn 4 into 1 is, again, to do that dividing by 4 step that we talked about earlier. Okay, but now, since there's only 2 terms left, it's much easier. And if I were to get a fraction, that fraction would be my answer at this point. So I'm basically done. So even if I end up with a fraction, it's not the end of the world. Okay, 4 divided by 4 becomes 1, which is what I wanted, because remember, this is 1x. Okay, and then 4 divided by 4 on this side is also 1. So that tells me that my final answer is x equals 1. Okay, now if you want to check yourself, okay, you can take this answer. Now I'm not going to do this on all of these, but you're welcome to check yourself as you do this. What I'm going to do is I'm going to take the original equation, x minus 2 equals negative 3x plus 2. Okay, so the original problem that we started with over in number 3. And I'm just going to replace anywhere I see an x with 1. Okay, so I'm going to rewrite the problem, but instead of using x's now, I'm going to use the number that I know x equals. So I'm going to put 1 minus 2 equals negative 3 times 1 plus 2. Okay, and remember, when you substitute a number for a variable, you're always going to want to use parentheses, okay? And it really, we can see exactly why right here, okay? Right here with this negative 3 times x part, okay? Because remember, this is multiplication. So in order to make it look like multiplication, well, if I don't put those parentheses there, it looks like 31, okay? And we don't want negative 31. We want negative 3 times 1. So I want to make sure I put parentheses around it to make sure I don't mess with that. Now the one on the left side here doesn't matter as much, but again, the parentheses are going to save your butt most of the time. Okay, and if you don't need them, then you didn't need them, but it's good to have them just to be safe. Okay, so let's just work out what we have. 1 minus 2, that is negative 1. Negative 3 times 1 is negative 3. Bring down the plus 2. And negative 3 plus 2 is negative 1. So now notice, negative 1 times negative 1, that is a true statement. That means that this answer is correct. Okay? If I was solving this, if I was checking my answer, if I plugged back in and let's say I got like negative 2 equals negative 1, which obviously is not what I actually got, that would mean that this answer is wrong. And that would tell me that I made a mistake somewhere in my original problem. Okay? But, because I know what I'm doing, we got negative 1 equals negative 1, so that means we are correct. Now, you don't have to do this step, but I would strongly recommend it. Okay, another option is you can throw both of these into Desmos, and it should be able to give you the answer that way as well. Okay, so use that to check yourself off. Okay, so that means our answer for this one is x equals 1. Okay, oh, one thing I forgot to mention as well. It says in the directions to use algebra tiles. Don't worry about using algebra tiles. Okay, we've never used algebra tiles. You may have used them in previous years. I don't really like them that much. We're just going to have you guys solve the equations. Okay, so don't worry about the algebra tile part. Just solve them. Okay? All right, now let's go ahead and take a look at number 6. Now this one, they're going to kind of lead me along the way, so I want to make sure I pay attention to what they're doing in this one. Okay, so I'm going to zoom in here a little bit so it's a little bit bigger. Okay, so notice we have negative 3r plus 9 equals negative 4r plus 5. Okay, and they've already kind of started the first step for us. They added 4r. Okay, and you can probably figure out why, because if they add, they add negative 4r and positive 4r, those numbers will go to 0. They will cancel out, okay? Because remember, if I have a variable on both sides of my problem, I have to get rid of one of them, okay? So I could have gotten rid of negative 3r by adding 3r to both sides, but I would have done the exact same thing they did. I would have added 4r to both sides because, again, that will leave me with a positive r when I'm done. Okay, so negative 4r plus positive 4r, this part goes away and becomes 0. If I add 4r on the left side, that will maintain my equation, right? If I do something to one side of my problem, I have to do the same thing to the other side. Okay, so now what do we need to get rid of next? Well, this r is already almost by itself, right? The only thing I need to get rid of here is just the 9. Okay, so that means if I want to get rid of a positive 9, right, because remember we look at this like a positive 9, I'm going to subtract 9 from both sides, right? If I want to do the same thing on both sides. Okay, so I do 5 minus 9, right? Well, if I take away 9 from 5, I can't actually do that without going into the negatives. Well, 5 minus 9, that is going to give me negative 4. Okay, and it turns out that is our answer for this one. So this one was pretty simple, okay? But even if, let's say, hypothetically, there had been another number here, which like you'll see in these problems, okay, where you have like a 5x here, okay? So let's say this said 2r was what we had gotten instead. Well, then I would just have one more step and just divide by 2, okay? But again, in this case, because r is already by itself, we don't need to go any farther, and this problem is already done, okay? All right. Looking down at number 9. Okay, so this one's going to be very, very similar. And again, I'm going to just pull to the side a little bit, give myself just a little more room to work with. 5y plus 4 equals 4y plus 5. Okay, and again, remember, the first thing I want to look at is I want to make sure that I only have one variable on one side of the problem. Okay, well, right now, I've got 5y on the left and 4y on the right. And I don't want both of them. I need one or the other, okay? So that means the first thing I'm going to do is I'm going to get rid of one of those, okay? And again, because I want to make it positive, I could subtract negative 5y, but then that's going to leave me with a negative 1y on this right side of the problem. And I would rather just keep it simple and give myself a positive 1y. So what I'm going to do instead is I'm going to subtract 4y on both sides, and that's going to leave me with 5y minus 4y, which is 1y, or in other words, just y. Okay, because remember that y and 1y are the same. So we might as well just make it simple and leave it just as y. Okay, so now we're going to bring down everything we didn't use. So I'm going to bring down the plus 4, and I'm going to bring down the 5. Okay, so now that I have positive 1y, this process is really, really easy because all I have to do from here is just isolate the y. Well, the only thing that's on that left side of the problem with the y is this plus 4. Okay, so I just have to work to get rid of the plus 4. Well, the way I get rid of addition is using subtraction. So I'm going to subtract 4 on the left side, and I'm going to subtract 4 on the right side. Okay, and that's going to leave me with y equals 1. Okay, now again, if I wanted to, I could go back in and plug in this answer back into the original equation. Okay, but just for the sake of time, you guys can trust me. I'm sure this is the correct answer. Okay, but you might want to check them on yours just because it's a pretty quick process. But just to keep the video from going too long, I'm going to skip that process on this one. Okay, so the correct answer here should be y equals 1. Okay, so last type here. This one is the word problem. Now, word problem ones. Now, I picked the hardest one of these word problems to do with you guys. Okay, but the rest of them are pretty simple as well, okay? And they all center around the same idea, okay? They mention a number. Okay, now that number is going to be represented by our variable, okay? So for 10 and 11, it's just follow what it says and see if you can figure out what it's saying in the context of the problem. Okay, number 12, this is the more real-world type problem, but it's very, very similar. Okay, it's going to be almost the exact same equations, or look very similar, just with slightly different numbers. Okay, so I'll take the hard one. You guys get the 2 easier ones. Okay, so number 12, 15 more than twice the hours Carla worked last week is the same as 3 times the hours she worked this week, decreased by 15. She worked the same number of hours each week. How many hours did she work each week? So we need to figure out what is the number of hours she worked each week. And it's important they told us that she worked the same number of hours each week. Okay? And you can probably figure out why that's important. Because if she worked a different number of hours in last week and this week, we wouldn't have any way to connect them. Okay? But now we know that it's going to be represented by the same variable, which I'm picking h because it's the number of hours. Okay, so we're going to take these two statements and we're going to turn them into the left and the right side of our equation. So we're going to have the last week be the left side of our equation, and we're going to have the current week, this week, be the right side of our equation. Okay, so the first part I'm going to do is I'm only going to look at the stuff from last week. 15 more than twice the hours Carla worked last week is the same as blah, blah, blah. We're going to skip the rest of that for now. Let's just set up the left side of our problem. Okay, so 15 more than twice the hours Carla worked. Well, twice the hours Carla worked is pretty simple, right? If I take the number of hours, which again is represented by h,
and I do twice that many, it's just going to be 2 times h, or double h, okay? But then I want 15 more than that number. So if I take the 2h, which is twice the number of hours Carla worked last week, I'm going to add 15 to that because it's 15 more. Okay, so in both of these problems, and really all of these word type problems, you're just kind of taking something that's in English and just translating it into math. Okay, so the way we make twice something is we double it, right? The way I figure out what 15 more something is, I add 15 to it. Okay, so I'm just kind of taking these words and turning them into numbers. Okay, so now I have the left side of my problem. Now let's look at the right side. So it says is the same as just meaning equals. So we can probably throw an equal sign on our problem. Okay, is the same as 3 times the hours she worked this week decreased by 15. Okay, so that means 3 times the hours she works, that would be 3h. And then it says decreased by 15. Well, when we did 15 more, we added 15. So decreased by 15 logically would be minus 15. Okay, so continuing on, now it's just the same basic process as before. I've got h's on both sides of my problem, and I need to get rid of one of those h's. So I'm going to subtract 2h on both sides. And again, the reason for that is I like to leave my variable positive if possible. Okay, so by subtracting 2h on both sides, that gets rid of the one on the left, leaving me with 15 on the right. 3h minus 2h is 1h, or remember, in other words, just h. And then minus 15 leaves me with minus 15. Okay, just bringing it down. So now, again, because I set up my problem the way I did, because I gave myself a positive h, I already have 1h. Okay, so that means all I need to get rid of now is just this negative 15. Okay, so the way I'm going to do that is I'm going to add 15 and add 15, and that's going to give me h equals 30. Okay, and again, remember, because this is a word problem, for the other ones in this section, they're just numbers, so you can just leave it as a number. But in this one, this 30 represents a real value. Okay, it represents a number of hours. So I want to make sure I label my values with the label that goes with the problem. Okay, so my final answer here, h equals 30 hours. Okay, so one last thing I want to mention is as you guys are working through this, a good section to go is to take a look at the other page that goes with this, the reteach page. This is going to have some other good examples to work from. So you have lots of examples now where it gives you kind of all the different ways that you can see what happens in these problems, okay? So use the models, okay? Because realistically, most of these problems end up being kind of the same basic idea. Once you kind of get in the swing of solving these, they become really, really easy. You just kind of need to start seeing the patterns. So compare these equations, okay, the ones that are on the reteach, plus the ones that I've already solved, and you can feel free to rewind the video and go back to them, okay, and use them to help you solve the rest of these, because this is the most important skill you do all year in 8th grade, okay? Because algebra and geometry and algebra 2, they are built on this foundation. You're going to be solving equations left and right in those classes.